Welcome you all. Myself, Dr. B. Manju, Professor and HOD of Chemistry Department, Maharaja Institute of Technology, Mysore. Today I am going to discuss about corrosion science and metal finishing chapter. First, we have to understand that what is meant by corrosion, now how it takes place, what is the causes of corrosion, and how can you control the rate of corrosion, and what are the variable factors to increase or decrease the rate of corrosion. They are going to discuss in details about in this chapter. Now first I go for corrosion. Now I say that corrosion is the reversible of metallurgy. How we can say that corrosion is the reversible of metallurgy? Now in the metallurgy chapter what you have discussed, now they are taken ore and you are extracted pure metal. The ore is naturally available in the earth crust either in the form of oxide, carbonate, bicarbonate or sulfide form. Most of the metals are available in the earth crust in the form of oxide. Likewise, iron ore is an hematite. Hematite is also one of the best ore of iron. Now, this containing more than 85% of iron content. Now, ore is in the combined form. Now, hematite ore formula is Fe2O3 3H2O. Now, that is the ore. Now what you are extracted, pure metal you are extracted by using metallurgical process. By using metallurgical process, you are extract the pure metal from its ore. Why you are extracted pure metal? In natural form, ore form, that is available in the earth crust. Now iron in the combined form. Always that combined form energy is less, stability is more. But we want variety of engineering applications, the strengthened metal is required. That's why you are extracted pure metal from its ore by using metallurgical process. Therefore, all the metals are trying to get their original state. That is a ore form, natural form. That's why all the metals are trying to get their original state. Therefore, they undergo oxidation. They undergo oxidation. When undergo oxidation, they undergo corrosion. That means corrosion is the reverse of metallurgy. In the metallurgy chapter, what you are discussed in the PUC level, pure metal you are extracted by using metallurgical process. But all the metals are trying to get their original state, therefore they undergo oxidation. When undergo oxidation, corrosion takes place. That means corrosion takes place due to oxidation. But oxidation is not an independent reaction. That will undergo automatically reduction also. Oxidation, reduction is a simultaneous process. Therefore, oxidation takes place, they undergo corrosion. Another part in the environment, they undergo reduction. Therefore, oxidation, reduction takes place, then they undergo corrosion. Now, corrosion is the reverse of metallurgy. That's why all the metals are trying to get their original state. They undergo oxidation. That is explained by theory satisfactorily. How the iron metal again is converted into Fe2O3 3H2O. That is I am going to explain later on. That's why all the metals undergo corrosion. Now you tell me that what is the definition of corrosion? Corrosion can be defined as destruction or deterioration of metals, metals or alloys. Not only metals undergo corrosion, even alloys also undergo corrosion. Destruction or deterioration of metals or alloys by chemical or electrochemical. By chemical or electrochemical attack by the environment is known as metallic corrosion. Metallic corrosion. Now that is the actual definition of corrosion. Corrosion can be defined as destruction or deterioration of metals or alloys. Metals also undergo corrosion, even alloys also undergo corrosion. By what reaction? Either by chemical reaction or electrochemical reaction in the environment, they undergo corrosion. That is called metallic corrosion. Now that is the causes of corrosion. Now causes of corrosion is like that. Causes of corrosion, because we are extracted pure metal from its ore, therefore all the metals are tried to get their original state, they undergo oxidation. When undergo oxidation, corrosion takes place. Corrosion takes place due to oxidation. But oxidation is not an independent reaction. Automatically reduction also takes place. Oxidation reduction takes place simultaneously in the environment. Therefore corrosion is the reverse of metallurgy, but this is the actual definition. Now we come to the types of corrosions. Next we come to the types of corrosions. Now corrosion generally classified into two types. Types of corrosion. Classification or types of corrosion. Corrosion can be classified into two types in general. One is dry corrosion or direct chemical corrosion. Dry corrosion or direct chemical corrosion. Second one is wet corrosion or electrochemical corrosion. Dry or direct chemical corrosion or wet or electrochemical corrosion. In general, classification of corrosion can be classified into two types. Now dry corrosion takes place only when the dry gases like air or oxygen on the surface of the metal, they undergo corrosion. For example, windows rod. We are not putting any water droplet on the surface. Only the moisture content present in the atmosphere is enough to undergo corrosion. That is the example of dry corrosion. Now dry corrosion takes place due to the effect of either oxygen or air on the surface of the metal, they undergo corrosion, that is called dry corrosion. Then wet corrosion takes place only when the metals are immersed in a liquid. The wet corrosion takes place only when the metals are immersed in a liquid, that is called wet corrosion. Now dry corrosion is explained by differential aeration theory of corrosion. Wet corrosion explained by electrochemical theory of corrosion. Now there are two theories explain the corrosion, because the differential aeration theory is failure to explain wet corrosion, how it takes place. Electrochemical theory is failure to explain how dry corrosion takes place. Therefore they are accepted both the theories. Dry corrosion explained by differential aeration theory of corrosion. Differential aeration theory of corrosion. Differential aeration theory of corrosion. And second one is electrochemical theory of corrosion. Electrochemical theory of corrosion. Now these are the two theories. Dry corrosion explained by differential aeration theory, wet corrosion explained by electrochemical theory. But as per your VTU syllabus, just electrochemical theory of corrosion you have to concentrate. Now electrochemical theory satisfactorily explain how the pure metal is again converted into Fe2O3 3H2O. I am going to explain later on. Now we come to the differential aeration theory. To understand the further classification of corrosion types, they needed the basic concept of differential aeration theory. The concept of differential aeration theory is less oxygenated surface. Suppose this is a less oxygenated surface, they act as anode, more oxygenated surface act as cathode. That is the concept of differential aeration theory of corrosion. Less oxygenated surface act as anode, more oxygenated surface act as cathode. That is the theme. Next come to the wet or electrochemical theory of corrosion, that is explained by electrochemical theory of corrosion. Now this is taken example to explain wet corrosion, how it takes place. Okay. I come to the theories. Now out of these two theory, as per your syllabus, now that is an electrochemical theory of corrosion. Electrochemical theory of corrosion. Electrochemical theory of corrosion. Now in this case, the mechanism of corrosion explained by electrochemical theory satisfactorily. How the pure metal again is converted into Fe2O33H2O by considering all possible conditions, they are explained it. Now in this case, just you consider iron piece. Suppose it's an iron metal piece. Because corrosion takes place either on same metal or on different metals. Suppose windows rod, that is the same metal, this is an iron piece. Some of the portion that starts corrosion, now that is explained by dry theory, dry corrosion, that is an direct chemical corrosion, that is explained by that. And different metals, suppose you take there are two different metals, one is an copper, suppose one is an iron, they are taking any two different metals, one of the metal undergo corrosion, depends on electrochemical series of metals, on the basis of electrode potential, which metal it has high negative potential, they act as anode, and other metal act as cathode. In these two cases, this is undergo oxidation, they undergo corrosion, this is free from corrosion. Now electrons are transferring from anode to cathode. Now corrosion takes place either on same metal or on different metals. Now this is an iron piece, there is the same metal. I put a water droplet on the surface. Now just I put a water droplet, just you can imagine that. Now I will put this water droplet into H plus OH minus. So I can write it H plus and OH minus. Now why I mentioned like that, suppose the water droplet either may be acid drop or maybe base or maybe neutral. Now we can easy to explain it. Suppose you take acid drop, they containing H plus ions. Suppose you take base, they containing hydroxyl ions. Suppose you take neutral solution, that is a water, that is H2O. Just you write this one. Now this is the theory, the electrochemical theory, the mechanism of corrosion explained by electrochemical theory on the basis of galvanic cell formation. Galvanic cell formation. What is meant by galvanic cells? The minute cells are created on the surface of the metal when electron transferring from anode to cathode. Now always electrons are transferred from anode to cathode. Now electron transferring takes place, some potential difference occurs. Due to the potential difference, a small galvanic cells are formed. Due to the formation of galvanic cell on the surface of the metal, they undergo corrosion. That is the mechanism is explained by electrochemical theory of corrosion. Now as per the theory, where oxidation takes place, that portion act as anode or they call it as anodic area. Where reduction takes place, that portion act as cathode, that we call it as cathodic area. Now the oxidation and reduction takes place simultaneously in the environment by traveling of or jumping of electron from anode to cathode. Always electrons are transferring from anode to cathode, they undergo corrosion. Now for example, that reaction is at anode the metal iron, they undergo oxidation. Now what is meant by oxidation? Oxidation means the removal of electrons, reduction means gaining of electrons. Now oxidation, the removal of electron, there is an iron metal undergo oxidation, they convert into Fe2 plus ion, iron ion or ferrous ion, plus the liberation of electrons. Removal of electron is the oxidation. Oxidation is always takes place at anode, reduction is always takes place at cathode. Electrons are always transfer from anode to cathode. Now at anodic reaction, the iron is converted into Fe2 plus 2 electron. Then you come to the at cathode. At cathode, the reaction is different, depends on the medium. Suppose you take acid droplet on the surface of metal, that reaction is different. Suppose you take that is a base, that reaction is different. By suppose you take neutral solution, the reaction is different in presence of oxygen or absence of oxygen. By considering all possible conditions, the mechanism of corrosion explained satisfactorily by electrochemical theory of corrosion. Okay. Electrochemical, excuse me. At cathode, I'll consider the different conditions. The first condition, suppose is an acidic. This is an acidic medium. Now in the acidic medium, what ions are available? In the acidic medium, always H plus ions present in that. The H plus ions present in the cathodic region, the electrons liberated at anodic region. Now these electrons are gaining takes place at cathode. At cathode always reduction reaction takes place. Reduction means gaining of electrons. Oxidation means removal of electron. The liberated electron at anode, they are accepted at cathode, undergo reduction. The H plus ions in the acidic medium, the gaining of electron takes place, that is converted into hydrogen gas. Now hydrogen gas liberated. Due to the liberation, continuous liberation of hydrogen gas, it will increase the rate of corrosion. That is another factor to increase the rate of corrosion. And then I come to the second condition. Second condition is neutral and deaerated medium. Deaerated means aerated means in presence of oxygen. Deaerated means absence of oxygen. Neutral example is water. Just you take that water is a good example for neutral solution. Then water in absence of oxygen, without oxygen. Now even water containing dissolved oxygen, suppose you can remove that dissolved oxygen also, they containing only H2O, then that reaction takes place at cathodic region. Water itself undergo reduction by gaining of electrons, that is converted into hydrogen gas plus hydroxyl ions, OH minus. Then I think all of you know that how to balance the equation. Now you can balance the equation. There is an 3 hydrogen. Suppose you can put here 2 into 2, 4 hydrogen. Then you can put 2 here, 2 oxygen, 2 into 2, 4, 2 plus 2, 4 hydrogen. That is the balancing. I think all of you know that. Okay. Then I consider the third case, neutral and aerated medium. Neutral and aerated medium. Neutral example is H2O. Aerated means in presence of oxygen and gaining of electron takes place at cathodic region. Oxygen itself undergo reduction in presence of water. Here water itself undergo reduction by gaining of electrons in absence of oxygen, but in presence of oxygen, oxygen undergo reduction by in presence of water, it convert into hydroxyl ions. To balance the equation, there is an oxygen, suppose you can put 2 here, 2 into 2 oxygen plus 2, 4, therefore you can write that 4 OH minus, that is an 4 electrons. Okay, that is the equation. Now this theory, electrochemical theory, by considering all possible conditions, acidic condition, neutral and an absence of oxygen, neutral and presence of oxygen. Then you come to the formation of corrosion product. Formation of corrosion product. Formation of corrosion product. Now in the anodic region, the liberated electrons are accepted in the cathodic zone. Then remaining is Fe2 plus ion. Now you consider that Fe2 plus ion present in the anodic zone. Come to the cathodic zone. In all the cases, now hydrogen gas is expels out. That arrow mark indicates there is a gas expels out. What is remaining? Only hydroxyl ions. Even consider base, they also containing hydroxyl ion. Therefore, Fe2 plus in the anodic region, OH ions present in the cathodic region. These two are reaction takes place. Iron react with hydroxyl ion, that is converted into FeOH twice, ferrous hydroxide. Just to balance the equation likewise, ferrous hydroxide. Ferrous hydroxide, it is an unstable, therefore this is further undergo oxidation in the environment. In the environment, water is available, oxygen is available, that is enough to undergo further oxidation, it becomes stable. Ferrous is converted into ferric state, ferric hydroxide. Ferrous hydroxide, that is further undergo oxidation in presence of water. In the media is available water and oxygen medium, that's why they undergo reaction in presence of water and oxygen. Ferrous hydroxide, that is converted into ferric Fe2O3 3H2O. Iron is 2, you put 2 here, then 2 into 2 4 oxygen plus 5, then you take off 1 plus 1 2, 2 into 2 4 6 oxygen, 3 plus 3 6 oxygen, there are 2 iron, then that is an hydrogen, 2 into 2 4 hydrogen plus 2 6 hydrogen, 3 into 2 6, that is called rust. That is the product. Now we can see, now this theory, electrochemical theory, the mechanism of corrosion, how it takes place, satisfactorily explained by considering all possible conditions, either in acidic solution if you put it on the metal, or base, or neutral, or presence of oxygen, or absence of oxygen. Final product is obtained, Fe2O3 3H2O. Now all the metals are tried to get their original state, they undergo oxidation in the presence of atmosphere available ions. Okay, that's why the corrosion is the reverse of metallurgy, because for our purpose, the variety of engineering applications, we are extracted pure metal from its ore by using metallurgical process. But in the combined, why you are extracted pure metal? Because we want more strengthened metal. The combined form strength of metal is less, stability is more. Therefore, we are extracted or separated from its ore by using some technique, metallurgical technique or process. Then pure metal is a more energetic, less stable compared to ore form. But they undergo oxidation always. In the atmospheric oxygen is enough to undergo oxidation and moisture content. Then finally get the Fe2O3 3H2O. Suppose it undergo corrosion, what will happen? The so many effects due to corrosion, conductivity it lose their valuable properties such as conductivity, malleability, ductility and strength. It lose their conductivity also, suppose that metal undergo corrosion, and malleability and ductility, that means it can be beaten into sheets, wires and sheets. Okay, that malleability it loses that property, and conductivity. Then strength, our main purpose to extract the pure metal from its ore to get a strengthened metal, but all the metals when undergo corrosion, it lose their all these valuable properties, conductivity, malleability, ductility and strength. That's why they needed to control the rate of corrosion. Corrosion is always takes place, but required some technique. They have some technique to control the rate of corrosion. Corrosion will happen, but corrosion can be controlled by using some technique. That's about electrochemical theory of corrosion. Okay.